All right. So one last topic while we're on the idea of silicates, let's talk about amorphous silicates. So all of those structures that we've just talked about with the O to Si ratio table, all of those were crystalline, meaning that they had long range order structures. However, silicates can also form into amorphous materials. And these are those materials that we think of as glass. So if you just tell somebody glass, chances are you're referring to the non crystalline or amorphous version of SiO2 with some other materials maybe in there as impurities or additives. But it's the same thing. The structure, we start with SiO4 and we build in a network, right? All of the oxygens are bonded to other silicon. So if we have it in the crystalline version, it looks very ordered, right? And we see kind of the hexagonal or honeycomb structure. However, if it's amorphous, these kind of everything is networked, like you can see. So the local arrangement, the tetrahedron, is the same, but the bond angles connecting everything are kind of off a little bit. And so instead of this honeycomb, we see these very kind of disorganized patterns. And so this structure over here has no long range order. And so this can happen naturally with just SiO2, so just building off of these structures. However, we typically add things to make it more disruptive and likely to form into these amorphous or non ordered structures. And so things that we can add, like sodium, can be added. And so you see here the sodium red, slightly larger red spheres are free ions. They don't. They basically break up the network and they act as free ions in the glass structure. And so it increases the number of non-bridging oxygens, which has some beneficial effects to the temperatures in which we can work this material, but it also makes it more likely to be amorphous. And so a common glass formula is the soda lime glass. This is probably, if you think of glass, this is the composition, the very cheap stuff that you're used to. The soda refers to sodium, the lime refers to calcium. And so this composition is mostly silicate, but it does have sodium and calcium oxides added to do this disruptive pattern, to lower the temperature, to make it more likely to form a glass. And so therefore it becomes more cost effective because we can do it at lower temperatures and still form this and easier to manufacture.